Welcome back, it's the Hawaiian Shirt Coder here again, and we're continuing on in our series of Web API. Now it's time to take a step back, draw breath and have a look at what we've done so far, and a few things I've done behind the scenes. Nothing scary though, let's take a look. So here we are back at our solution. I just want to show you some of the things that we've been doing between videos. So we've come quite a long way with various bits and pieces, and what I'm going to show you now is a bit more of the code that looks in a more complete state. This on first view will look a little bit daunting, but it hasn't really got anything new in it that I haven't shown you in the previous videos. It's just got a lot more code, so it's a lot more complete solution. So up to this point, all the work we've been doing has been based around the player controller and implementing all of its verbs and using a few best practices like data transfer objects and data validations. So all this little video clip is showing you is that I've applied these to the other areas of the system, which are fixtures and availability. So let's just show you the solution at the time of recording in this taking stock episode. So if we expand out SMS API, you can see in the controllers now, rather than just having a player controller, we now have a fixtures controller and an availability controller. So that's the first thing to notice. If we go down to the shared library, you will see a few more things in here as well. So first of all, if we open up the DTO folder, I have, for neatness, don't need to do this, but I've done it as I've actually created subfolders so you can see which model entities have DTOs. So all the availability DTOs live in this folder, all the fixture DTOs live in this one, and all the players in this one. So if we just expand these out, you can see we now have a lot more DTO objects than we did when we were just talking about DTOs in the DTO video, where we just focused on players, and I think we created these two. Again though, even though there are more files here, it sort of works very same sort of principles. So for example, when we post in a fixture into the system, it looks much the same as when we post in a player into the system. The only bit that is different is we've removed the ID in both cases to make it a DTO object rather than a model. Where you'll notice the most DTOs is to do with availability. Now availability is still this magic piece in the middle that we're not completely concerned about for the purposes of the Web API series, but it is the one that involves the most complicated data transfer objects because it's a link table. It's basically needing to get information from both the fixture and the player tables or models and merge them together to get some meaningful information out, because really the availability table in the database just contains IDs, but we won't worry about that at the moment. All I want to show you now is what the Swagger documentation looks like based on these changes. So if I fire that up and drag it across onto the screen, you can see the Swagger documentation has a lot more endpoints you can now hit. So through all our videos, we basically have been creating all of these under player, and now we can get fixtures, we can post fixtures, we can get one particular fixture, we can delete a fixture, and we can update a fixture. So let's just have a look at those to start with. Again, all of this information is still, at the time of recording, running off our in-memory fake database or list of objects, even though we have done the groundwork and created a database in SQL Express. We haven't hooked up our code to it yet, so all the results coming back from here are from in-memory. So let's try each of these out. API fixture, no parameters, try out, execute, and we get a list of fixtures back. So that works exactly the same as get all players, it's just a different set of data. If we just bring up the code just to show that, just to prove there is no magic there, go into the API and then into the fixtures controller, and here we go, get all fixtures using a HTTP get verb. Go into the in-memory database that now has a list of fixtures and returning it back. So just to show the in-memory database, previously it just had this list of players that's hard-coded. Now what we've got is we've got a list of fixtures that's hard-coded, and further down we've even got a list of availabilities, which are, like I said, just a series of IDs. So on the face of it, don't mean a great deal. So back to the screen. So that is showing all the fixtures. Let's close that one up. We can also go and get a individual fixture by its fixture ID. So let's say get me back fixture 2. There we go, there's fixture 2 against Liverpool. We can also add in a brand new fixture, and we can do that with a post. And you will notice if I flick on the scheme here, we're not supplying a fixture model object. We are using an add fixture DTO, which is decoupling us from our internal representation of the data, and so getting away from causing potential breaking changes or exposing bits of information that we don't need, or if we need to shape the data in a different way, the data transfer object that sits in between what the user is sending and what gets posted into our database helps us do all of those things. So let's just go back to this and try it out. I'm just going to leave all the values basically. Maybe I'll change this one to Gloucester. Actually, need to try it out first of all. There we go. Gloucester Rugby Football Union Club. And we'll say it's home, and the start time is 1500. This is NA, and the number of players we need for a rugby match is 15. And that will do for now, I think. So just to give an example, and if we post this, we should hopefully get a 201 back, and it's posted it into the database. And again, if we look under the get all fixtures, we should now have Gloucester Rugby Union in here as a fixture. There we go. So the post is working, so that's great. If we just close that one back up, let's have a look now at the delete. So let's go and delete out Gloucester Rugby. So in here under the delete, we just need to supply the fixture ID, and the fixture ID is 4. We go delete, and you can see I'm returning, rather than an OK, I'm returning a 204 no response. So basically you don't get any data back, so we need to go and use our get all fixtures just to check that Gloucester Rugby isn't in there. So at the moment it is. If I go execute, we can see now when we scroll down that it's gone, so the delete's working fine. Let's just close this up, and finally let's have a look at the update, which, surprise surprise, should also work. And again, all of these follow exactly the same pattern as when we were walking through in a more detailed dive the player approach. So there's nothing new here. There's, like I said before, there's just more of it. So we go put, and for this one we'll update record 1. In fact, let's just see what record 1 is before we continue. Record 1 is against Southampton. So let's just change Southampton to something else. Close that up. And we're going to supply 1 for the ID, and then 1 in here. And we're going to say the opponents are no longer Southampton. We're going to say they're the Saints. We'll leave all these other fields, but you get the gist that we can change all of this stuff as we want to. All we're interested in is, does record 1 from being Southampton change to Saints, or Saint. If we go execute, we get a 200 back, and we get the record that it's just changed post back to us. But just to prove it again, in our get list, we close this up, execute, and there we go. Record 1 is Saints. One thing I probably still need to do is make sure they're ordered by ID when they come back in the list, but that is correct. So that's all our fixture stuff done. You can have a look through the code and you'll see that it doesn't really look a great deal different to how the players stuff worked. So let's just have one final look at that. So the get by ID is going off and querying the in-memory list based on the ID. If it finds nothing, returns a 404 not found, otherwise returns the fixture in question. The add fixture uses a DTO object to pass in the data to post a new fixture into the system. We're still using this piece of hacky code to simulate a database to generate the ID field. This will disappear as we progress through the videos towards a data access layer. Here we have our delete fixture, where we just pass in the ID. It goes off and tries to find the record in the fixtures list of the in-memory database. If we can't find it, we get 404. Otherwise, we remove it from the list and return no content. And then finally, the update, where we pass in the ID and the fixture, and we go through and we how we've implemented it, same as the player one. Could be better ways of doing this, but this is just how I've done it for this demonstration. Is I find the record, remove it from the system, then re-add it and reapply the same ID. So there we go. So if we go back to the web API now, the other bit that I've added is availability. So availability, like I've said before, is this link table. A fixture can have many availabilities. An availability must be for a fixture. A player can be available for many fixtures, and an availability must relate to a player. So it's this link table in the middle. In terms of what it holds, all it holds is it holds the IDs that link a fixture to a player and vice versa. So if we have a look at the in-memory list again, which is in the fake database, you can see under availabilities all it's holding is a fixture ID. So fixture ID 1 was Southampton, player 1 is John Smith. So what this is saying is John Smith has made himself available to play in the game against Southampton. But on the face of it, it's just a list of IDs. So this controller that we've created, availability, has these endpoints, and this one is a little bit more complex in nature, and I will show you this in more detail in a minute. But for the meantime, I just want to show that these also return data now, and that we can specify whatever route we like, which I'll also show you when we dip into the code. So this top one is saying what are all the players that have made themselves available for a particular fixture. So let's try this one out. This one is just asking for what is the ID of the fixture. So you can imagine in an application this may have a list of fixtures on the screen, and each fixture's name, so Southampton, may be a hyperlink, but when you click on the hyperlink it is passing the fixture ID in the background into this API, for example, and this API will go away and say give me all the players who've said they are available to play in the game against Southampton. So let's try that out. So Southampton is fixture 1. If I go execute, scroll down, we get a 200, which means it's successful. It returns back some information. It returns back that the game is against Southampton or Saints because I updated it. So on this day it's at home, and here are the players who have said they're available to play in that game: John Smith, Peter Parker and Ben Stokes. So basically in the underlying database table or in memory list we'll have fixture 1 with the record with the player 1, fixture 1 with the player 2 and fixture 1 with the player 3, and this is involving joining the data up. And through a DTO, if we just clear this back, so the second API call that we've got is player availability summary. So given a particular player, say Ben Stokes is a player in our system, if you supply his player ID it will bring back a list of all the games that he's signed up to play in. So let's try that one. So it's the opposite way round of this one really. So if we go into here and we say show me all the fixtures Ben Stokes is available for, we put in number 3, we get a list back. It confirms that player 3 is Ben Stokes, and he's got a thing in here, an array called My Fixtures, and he said he's available for the Saints game and he's also available for the Liverpool game. Then the final one that we've got for getting information is to supply a summary of all the fixtures in the system and how many players, or a count of how many players, have said they're available. So let's have a look at that one. No parameters required for this. And if we go execute, you can see for player 1, which is the game against Southampton or the Saints, 3 players have made themselves available for that game. We actually need 11 players in total to field a full team. And then against Liverpool, fixture 2, we currently have 2 players who've made themselves available, and again we need 11 players. How this works at the moment is if there is no information in the availability table, we don't get any records come back. Which basically is saying we don't know about the fixture and we don't know about the players who signed up to it. There's nothing in the table to join outwards to the other 2 tables. So let's close this one up. And then finally we have created a method of adding your availability to a fixture. So let's go into here, and this is very simple. It's just saying give me the fixture ID that you're available for. So let's say the Liverpool fixture, which is number 2. And also give me the ID of the player who said they're available for that game. So let's say 2 for that as well, which is Peter Parker in our example. In fact, let's say 1, John Smith. And also supply if they're available or not, which will become more apparent what this means when we actually look at the code. So if we execute on this one, we've got breakpoint in this case. Let's just step through that, and we get a 200 add availability for this fixture. Not very good English. You can always change the message later. And if we go back to, we can look at it either way around now. So we could go back to this one. So give me all the players who are available for fixture 2. So we're expecting player 1 in this list. Let's just see if that is actually true. So fixture 2 now has John Smith, which is the one we've just added, and Ben Stokes available. So that's good. How this also works is based on this entry. If we now change this to false, so it's still John Smith, it's still the game against Liverpool, fixture 2, but basically if you imagine the user interface is maybe a checkbox where you check the box to say you're available and you uncheck it again to say you're not available, that's what this is available is. So basically he's unchecked the box to say I'm no longer available for that game. Go execute. Hit our breakpoint, which we forgot to take out. Follow on that. And we get a 204. No content response back. So if we go back to this one again, rerun it. So previously John Smith and Ben Stokes are available. Now it should just be Ben Stokes. And there you go, it's removed it again. So the post is sort of multi-function in this case, how I've implemented it at the moment. So yeah, so that's just walking through all the new endpoints we've added. Like I said, they are using the stuff that we've covered through all the videos so far. They are using data transfer objects where possible rather than models. They are validating fields, so required fields will bring back a 404 if they're not, a 400, apologies, if it's not completed as a bad request. And all the sort of stuff like that. So yeah, nothing new, just a lot more of it. So I encourage you just to peruse the code to get familiar with it. Let's look at some implementation details. Let me just show you another implementation detail that I've added to the Fixtures Web API. So this is a little bit that varies from the stuff we've done with Player, but I just thought I'd show it you out of interest. It's not anything particularly to do with the development of a web API, it's just an implementation detail. So if we go to the Fixtures, previously for Fixtures we enabled the property of venue to be a string, so the string could have anything in it. All we really want in it is home or away. So what I've done is I've replaced this with something called a venue enum, or an enumeration. We just F12 on this. Our enumerator has 2 values, home, which equals 1, and away, which equals 2. And those are the only valid entries that you can put for a venue. I've added this also to the DTO of add fixture DTO. So if we have a look at that, that also has a property using venue enumerator. So again, when someone posts in that information, that is what is expected. We've also added this specialist attribute that's to do with enumerations, to say, well, we're expecting something that is of type venue enumerator, even though the JSON in the background is passed through just purely as a string, and if we don't get that, we'll pop out this error message. So let's just see what this looks like actually in the Swagger documentation. Let me drag this over. We'll close up availability and we'll close up player. If we go to post and go try out, you can see venue now is set to 1. So we know 1 purely from looking at the code equals home, and 2 equals away. So let's just try this. Execute, hits our breakpoint. Let's have a look at what's passed through. So 1 was passed through, it knows that 1 equals home. So if we go F5, we should get a 200, and that's posted that into the system, so that's good. Let's try this time with 2 for away. Let's post this through again. Here we go on my breakpoint, and again it's picked up that that's valid because it's put venue as away. So if we hit F5 on that, that should also return us a 201. Success. Now, out of interest, let's try an invalid integer. Let's try 3. So don't know what 3 is. The system doesn't know what 3 is. Let's see what happens. So if you come down, you get a 400 out of the box, and it says value must be home or away. So the validation's getting picked up, and that entry has not been posted to the back-end database. So that's good. However, I can see a flaw with this. So a consumer of our web API may come and have a look at our Swagger documentation, and most of these fields are pretty self-explanatory. Putting an opponent as a string, a date, the time the match is on, and the postcode and number of players. But this venue thing, we don't really know what that means by looking at the documentation. We can click to the schema mode, and the schema mode will say, oh, venue is of type venue enumerator, which is an integer, and then it will give us a list of the valid enumerations for that array, and the valid entries are 1 and 2. However, that still doesn't help the end user very much, because what does 1 represent? We know it represents home, but they don't. So we need to make a tweak to this so it's more meaningful for the end user in understanding our web API. So let's stop this running a second and go to the code. And in order to do this, we have to make one change to the program CS file, where we set up all the configuration of our web API and our middleware. So when we're adding the controllers into the middleware, we need to add something called JSON options. And I've commented it out at the moment, but I can uncomment this one line. And this one line is basically saying convert JSON string enumerations. So it's going to convert the 1 into home and the 2 into away, which will be more meaningful to the end user. So we just need to bring in this namespace for the JSON serialization. We spin this up again now. And drag it across again. There we go. And then close this one up. And if we go to fixture this time, you can see we now have a meaningful example to work with. And also if we go to the schema, it's replaced 1 and 2 with home and away, which makes more sense to someone reading this documentation. So let's go back to this, just try it out again. So we try it with just home. Again, we hit our breakpoint, still comes through as home, everything works, still get a 201. Let's try it with away. Hit execute, hits the breakpoint again, through we come, says away, should still get a 201. There we go, that's added that in. Let's try a string that isn't valid for the enum. Let's try QWERTY. And we instantly get a 400 error. And the message this time isn't as helpful, but at this stage I've left it like this. The key point to take away is the data is badly formed, so it hasn't got submitted to the database. So this is the important bit. We get a 400. We can work on customizing the error message later, because that's not a very user-friendly error message to return back to the user of the system. But yeah, that's just showing the use of an enumerator in our taking stock of what we've done so far. So based on changing our venue to use an enum rather than a string, that has also had another implementation detail impact somewhere else in the system, and that is in the underlying database. So previously, when this was a string that it was accepting in our database, we also expected to have a string or an nvarchar. So what we need to do now, this is now in essence an integer, is change the data type of the venue column in our database. So let's go to SQL Server, and if you followed along in previous videos where we created the database, even though we're not using it yet, you should have a database that looks like this. SMS has 3 tables: availability, fixtures and player. You will notice in the fixtures table, if you expand it out and have a look at the columns, my venue field is now an integer. Now what you need to do in order to bring your database into line with this is go across to the solution, close the API section to make a little bit more room. I've got the database currently unloaded as a project, so let me just reload it. There you go, and you'll notice previously we just had one SQL script called createDB, and in the createDB, we just expand this up a second. We go down to the fixture part. Fixture was an nvarchar. So I'm assuming if you're watching this video you've ran all of these scripts, so your database is in this state at the moment. So in this taking stock series, I have added in the amendment 1 SQL. So this is where we're making a change to our underlying database schema. And what you need to do basically to put your database into the same state as mine is, once this one is run successfully, you need to run amendment 1. Amendment 1 is just simply doing 3 things. The existing data that is in the fixtures database, it is swapping anything that has the word home in it to have the integer of 1, and it's swapping anything that has the value of away in it to have the integer of 2. Then the final thing it's doing is it's changing the underlying data type for the venue field or column from an nvarchar to an integer. That's all it's doing. So all you need to do in order to bring your database into line is to open up this file, copy it into the clipboard, then close this file, open up the SQL plane over here, and then on SMS go to new query, paste your query that's in the clipboard into there, then hit the triangle, and then that will update your database so it is in line with the one that I've just shown you. So I also thought it'd be worth just discussing some of the implementation details to do with the availability endpoints, as we haven't really talked about these at all. And if you recall, in the background in the database, an availability table consists of two fields, a fixture ID and a player ID. But ironically, this set of endpoints are probably the most complicated in terms of the querying that we need to get back useful information, because on its own the availability with those IDs isn't very meaningful to an end user. So the availability endpoint needs to perform joins against both the fixture and the player tables in order to bring back some meaningful information. So for example, when I open this one up and I say give me the players that are available for fixture 1 in the system, we get quite a complicated structure come back with all the fixture information up front and then basically an array of players who have made themselves available for that fixture. So again, this isn't anything particularly to do with web APIs in question. This is another implementation detail that I just show you how it works in the background. I'm not saying it's the best way of doing it, but it's how I've done it for now, just so we've got a working example. So let's drop over to the code, and I'm in the availability controller, and we've got a method or endpoint for each of the GET requests that you saw on the Swagger documentation. So here's the one that will give us all the players for the given fixture, so the one that actually tried out. And all I want to show you with this is a couple of things. Is that, like I said, we're not just getting stuff from the in-memory availabilities table, we're actually getting stuff from also the fixtures. So what we need to do is join fixtures to availability with this join, where there's a match on the IDs and where it is the fixture ID that we passed in as a parameter, and then we are doing a projection to create our DTO that we send back to the requester, in this case a player available for fixture DTO. Like I've said in previous videos, producing that data transfer object can be achieved in multiple ways. I've just done it here for simplicity as link projections. You could do it using the AutoMapper third-party NuGet package, like I said, or using extension methods. So that's just two other examples of how you can create that object-to-object mapping. If we have a look at player availability summary, so that's much the same. We're just getting the players in this case, and we are creating a DTO, and then we're going and getting the fixtures, and we're basically combining the two DTOs together to create our complex object and return it to the user. And then with counts, what we're doing is we're actually using links aggregate functions by using a group by in order to give us some counts of how many players are available for a given fixture. So as you can see, these endpoints are far more complicated than the player and fixture endpoints because of the joining. But we'll see as we go on how we can remove some of this complexity from our controllers. Our controllers shouldn't need to know how to do all of this stuff. All they should need to do is handle the request coming in and delegate it to something else that will handle this complexity. Wow, that was a lot longer than I intended, but I hope you found it useful to see all the things I've been doing in the background. But as you can see, most of it is duplications of what we've done in our previous videos. Next, we can move on to splitting our application into tiers and doing away with those fat controllers. Stick with it, you're doing well. So I'm the Hawaiian shirt coder. That's the end of this session. Please remember to like, subscribe, share with your friends. Remember, keep learning, keep exploring, keep developing, and I'll see you next time.